All right, for this video, we're going into a little bit more on Dutasteride as a hair loss treatment, and the main goal is to try to figure out dosing. So the search, which I tried to pretty thoroughly look through PubMed, find every clinical trial that I could. The best I can find, this is the only one where they went above the 0.5 milligram dose that is generally considered standard treatment now. And so they actually did a handful of different things. They used multiple doses of Dutasteride. They used a placebo control, and they used a relatively high dose of finasteride. And they compared primary outcomes like hair growth. They also compared side effects. And interestingly, they also looked at plasma or blood testosterone and DHT levels. So we get actually quite a lot of interesting information out of this. Right, and the time frame is 24 weeks, which is should be more than enough time to see effects. Okay, so baseline demographics and study setup. So number of subjects allocated to placebo, and then a handful of different doses of Dutasteride in milligrams. One interesting thing about this is they don't really do any adjustment based on body size, and so these doses are given regardless of how large the person is. With a lot of drugs, you kind of expect when you're doing a clinical trial that you'll adjust based on body mass. They didn't do that, but it doesn't seem like it's that big of a deal. So they went all the way from 0.05 milligrams up to 0.1 to 0.5, which is the most common dose given, and then a fairly large jump to 2.5. Right, so relatively large increments, compared all that against placebo and against a 5 milligram dose of finasteride, which was on the high side. Other trials that we've seen used 1 milligram of finasteride, so that's significant. Total sample size 416, approximately 65 to 70 people per group, which isn't too bad. And then all of these things, baseline hair count, age, stage of hair loss. These are all baseline values just to show that they were relatively even across groups after normalization. So no one group had some, enormous advantage or disadvantage as a starting point. Okay, so the thing that we're most interested in, what is the change in hair count? Right, and they're doing this as just number of hairs within a defined area. 1 square centimeter on the scalp in a particular area is a pretty common measurement. And unsurprisingly, in the placebo group, hair count went down very slightly. I was actually kind of impressed that the 0.05 milligram dose, right, incredibly small, had an albeit fairly small impact, but it was considered statistically significant. From there, as expected, with a dose response, the average hair count went up. Interestingly, there wasn't really a lot of difference between the 0.1 and the 0.5 dose. All of these asterisks and error bars are showing statistical significance compared to the placebo, and so unsurprisingly, they all did significantly better than placebo. They did not do statistics from, or at least in this graph, they're not reporting statistics comparing these groups against each other. And so you kind of have to eyeball it. But my take on this is these peaks are not really all that different from each other. And so it's hard to argue for a huge increase. It's there, but given how big the error bars are, remember, these sky-high error bars mean there was an enormous amount of variation, right? And so some men in the study were doing incredibly well on these doses. They don't show you the bottom half of the error bars, but they likely came down, a similar distance as the high end did. And so some people probably had minimal, if any, change. All right. The 2.5 dose, same thing. I mean, we see a trend. It's going up, but going from the 0.05 to 0.1 gave us a relatively large boost percentage-wise. These increases, they're there. There's definitely a trend up, but it's hard to argue that the difference between the 0.5 and the 2.5 group is dramatic. Right? Not all that surprisingly, they all did significantly better than finasteride. Again, just by eyeballing it, I would say that finasteride is close to the 0.1 milligram dose of dutasteride, but probably slightly lower. Again, we would need direct comparison of those two groups against each other to see if it's statistically significant. But again, big takeaway, the size of the error bars and the sample size they had makes me feel pretty confident that there's definitely a slight trend upward in improvement. But, we're talking about differences in hair count that's, a 10, 15% increase from the 0.5 milligram group to the 2.5 milligram group. All right. Okay, and then this is just showing effectively the same data. And in all of this, the white bars are 12 weeks and the dark bars are 24 weeks. Okay, so same thing for just a few different measurements. So this is, vertex is the back of the head, whereas frontal is a person's hairline. And so same concept. Here we see, I think this is a slightly more convincing trend, right? And increase across the board. Again, the biggest increases come on the low end. And then by the time we get to, go from 0.5 to 2.5, it's there. It's relatively minor. So again, I think that there is probably a convincing difference between the two, but the error bars overlap a lot. Same kind of story as before. Okay, so main conclusion from this, does the 2.5 milligram dose give a significant benefit? I would say yes, but a small significant benefit. It's definitely not huge. And it seems to affect hairs all over the head. The patterns look very similar to me, whether we're at the hairline or in the back. Okay, next question. It's impossible to really nail this down with any kind of certainty, but the question that they're trying to ask is, can they prove that the mechanism holds up, meaning that is the effect of dutasteride and its dose directly a product of its ability to reduce DHT? Right? And so what they did was they measured serum or blood DHT levels and testosterone levels over time. All right, and interestingly, I really like this. The treatment, remember, lasted 24 weeks, but they then came back and took a 36-week measurement. And so if you look at their data, by the time week 6 rolled around, DHT levels had stabilized. All right, this is really interesting to me because, remember, we talked about last time we met, the half-life, or T-half, of dutasteride is about 5 weeks, right? So we said that it would probably take 20-something weeks to reach steady state. So what's interesting is the amount of dutasteride in the blood is definitely going up from week 6 to week 12 to week 24, but the drop in DHT is not progressing, right? So at week 6, they hit a steady state level of DHT anyway that stayed stable, right, from week 6 through week 24. That's really interesting to me, and it suggests that something, some sort of compensatory mechanism is going on here that we don't really completely understand. And I can't particularly explain it, but this is odd. The expectation would have been that if dutasteride levels are going up from week 6 to 24, that DHT levels should have continued to go down, and they just didn't. So I can't explain that. It's interesting, but the mechanism is unclear. All right, the change in testosterone, actual free testosterone levels went up over the course of the study, and that might initially seem weird, but remember that testosterone is the substrate that's used for the 5-alpha reductase enzyme to produce DHT. And so it makes sense if we're inhibiting this enzyme and making less DHT, that makes sense why you would have more testosterone, because that testosterone in the blood is not getting converted into DHT, so it stays in its original form. Okay, so this isn't surprising. DHT levels down, free testosterone up, and that just even further adds to the conclusion, because testosterone levels did continue to go up throughout the trial, right? An increase from week 6 to week 12 and from 12 to 24. And so why DHT stabilized when drug concentration and testosterone levels kept increasing? Very confusing. There's got to be some other pathway or compensatory mechanism that we don't know about. All right. So what we can do then is ask, all right, how much do these results explain the actual hair regrowth? And so what they did is, for every one of these conditions, different doses for dutasteride and finasteride, they plotted those with change in hair count on the Y and DHT concentration change on the X, right? And as expected, if you get lower levels of DHT, which would be down here, you get higher levels of hair regrowth. And as the change in DHT becomes less significant, right, then you get lower and lower changes in hair growth. And so all this is really proving is that the power of dutasteride, or finasteride for that matter, is really in its ability to lower DHT. That's the mechanism which we expected all along, but it's good reinforcement for that. Okay. This table is an interesting follow-up on the data that I think, this gets left out of a lot of published papers, and it's really interesting. So what they're really focusing on is the idea that when you see a graph that has error bars, you know there's an enormous amount of variation. And what we're kind of curious about is, since this all comes down to percentages, right? What percentage of patients benefited from a treatment? If all you get is an average, that doesn't really tell you, okay, what proportion of people in the trial got a massive increase or benefit, what percentage got a mild benefit, what percent didn't change at all. And so what they're doing is they're showing individual numbers of people and individual conditions. Okay. And in this particular case, they're looking for side effects. And so I like this, that instead of showing averages and error bars, we want to know how many individual people suffered those side effects, not what was the average rate of side effects in a bar graph or something. That wouldn't really be all that helpful. And so we have our adverse effects over here, obviously things that we don't want to happen, which are pretty much all, sexual disorders, because, DHT and testosterone in men has a pretty strong power over sex drive and function. And so same thing, placebo, which, is obviously showing us that there is some baseline level of these things happening, even without the drug. It could be psychosomatic, could be placebo effect, could have been pre-existing. Hard to really say for sure. But all we can really say for sure is that the 0.5, 0.1, 0.5, and the finasteride dose for all of their different measurements didn't look dramatically different than the placebo numbers, all hovering just very, very low single digits. And what we can say for sure is the only thing that looks like a really significant change is a decent number of people. So 9 out of 71, which is 13% of men on the 2.5 milligram dutasteride dose showed decreased libido, right? Which wasn't nearly as severe as these complete loss of function symptoms that they're showing below. But I think this is where the real, root of the 0.5 dose came from, is from our previous figures. The 0.5 milligram dose seems to give hair regrowth that's 80 or 90% as effective as 2.5. This bump in side effects was enough to convince FDA regulators, powers that be, maybe even the company to try to avoid the stereotype or the impression of side effects is, okay, is there an increase in effectiveness going from 0.5 to 2.5? Yes. Is it worth this increase in side effects? That's kind of up to every individual person to decide whether that risk is there. But that's probably the number that was really at the root of deciding that this dose was considered a little bit too strong. All right. Okay, so the last thing that I wanted to do on this is just a little bit of follow-up on the concept of half-life, steady state, the amount of time that it takes to reach half-life. So we talked about this a little bit last time. The half-life of Dutasteride is incredibly long, like very, very unusually long, at 5 weeks. Most drugs have half-lives that are measured in hours, usually single-digit hours. 2, 3, 4, 5, 6 is very, very common. 10 to 20 is considered a pretty long half-life. 5 weeks is just insane. I don't think I've ever come across a drug that has a half-life that long. Right? So if the half-life is incredibly long, that means that the dose can be very low. Right? So the way that this typically works is if this is some hypothetical drug and we're dosing it every 4 hours, right? And our half-life is 4 hours because at time 0, right here, we gave a dose that pushed this, imagined person up to 100 micrograms per milliliter blood concentration. And over the course of 4 hours, some combination of the liver metabolizing the drug and the kidneys excreting the drug brought our concentration down to 50, which is exactly half of what we started with. And so half-life for this drug is 4 hours, which is incredibly normal, right? And then we dose again, and this time we boost up to 150 because we were at 50. We gave another dose that the first time pushed us to 100, so now we're at 150. 4 hours later, we come down to half of 150, which is 175. Give another dose, push us up to 175. And you can see the further you go, these numbers start to stabilize, right? 88, 188, 94, 194, 97, 197, until eventually you're going to hover around 100 and 200 because you boost to 200, you come down to 100 every 4 hours, you dose again. That will just keep happening over and over and over again. This is considered steady state. And by the time we get to around here, remember I said about 4 to 5 half-lives, this is pretty much steady state, right? The longer the half-life, the longer it takes to reach that point. Okay, so if we were going to do this same graph for Dutasteride, since the half-life is so unbelievably long and you're only dosing once a day, instead of measuring this in hours, we would be measuring this in days or even weeks, right? And the line would look like this, right? Very, very, very slowly going up over time, right? Because you're dosing every day, which is much, much smaller amount of time than the half-life of the drug, right? And so it will take you a really, really long time to get there, right? They estimate that that the steady state will eventually be 40 nanograms per mil. That's the final dose that we expect to see in a person's blood, but that it will take about a month to get to 65% of steady state levels and approximately 3 months to hit 90% of steady state levels. You wouldn't really get to full steady state for probably more like, 5 months or so. Okay. And so that also means that if a person stops taking it, they'll have, some meaningful amount of Dutasteride in their body for quite a few months afterward because it takes such an incredibly long time to wash out. Okay? And so the end conclusion from that is, a loading dose could be used to hit steady state much faster as long as you then back off from the loading dose. And of course, most people don't have the tools available to measure levels in their blood. And so if you're going to do that, you effectively have to use a very theoretical modeling like this, but these things tend to be overall very accurate. All right, like always, Hope this was helpful, and I will talk to you again soon.